Hello, everyone. Welcome to this video on hypothesis testing involving two populations. This is section 9.1. If you've been following along in this series, you know that we've been doing hypothesis testing for a single population for some time now. We did hypothesis testing for one mean in section 8.2. when we knew sigma and we generally had a large sample size, we used a z-test. And then if the sample size generally were smaller and we didn't have sigma, but we had asked the sample standard deviation, we used a t-test. We did that in 8.3. Then we went on to the test for proportions, a single proportion in 8.4. And we just finished testing variances and standard deviations in 8.5. In this section of chapter 9, we're going to cover hypothesis testing for two means. So you're comparing two populations with each other, and you're comparing those means with each other. So let's begin by taking a look at the homework for this section. So it says, explain the difference between testing a single mean and testing the difference between two means. So, okay, if you want to say that, then you're going to say something like this. Doesn't have to say exactly this, but something similar. So you're going to say the difference between testing a single mean and testing the difference between two means is that when testing one mean, the parameter is compared to a specific value. When testing the difference between two means, the values of both parameters are compared to each other. Something like that. And we're going to see more about what that means. That's not as complicated as it sounds. Let me give you a brief little example before we start. So you know that when we test one mean, we get something like mu equals, say, 72, right? And our alternative hypothesis H1 could be something like mu is less, or we'll use not equal to. We'll use not equal to. We can have this test going in any of the three directions, just like before. I'll use not equal to in this case. Mu is not equal to 72. That's a single mean, okay? So this is stuff that we saw in either section 8.2 or 8.3. We were doing this, okay? Now we're doing stuff like this. Suppose that I want to test say the average age of students in my statistics class and the average age of the students in my geometry class, right? So I wanna test the mean, the population mean, not just the sample, but the population mean. I wanna see if they're different, right? So I could compare something like mu, and I'll use a little subscript here to differentiate them. The mean of the students in geometry here is equal to the mean of the students in statistics, for example, right? Mu of statistics. I have to use a little subscript or something to differentiate them because they're both mu, but they represent different groups. So mu of the geometry students is equal to mu of the statistics students, and this should be HO, not H1. I made an error there. Let me fix this. This should be HO, right? So, because this is my null hypothesis. So this is my HO here. Anyway, and I have mu of the geometry class right here, for example. So that's either equal to versus not. Now my H1 is that this is not equal, okay? So my H1 would be something like H1 would be mu of geometry is not equal to mu of statistics, let's say. And I would perform, there's appropriate testing to perform for each one of these. Now, that's my example, right? This is the difference. So the difference between testing a single mean and testing the difference between two means is that when testing one mean, the parameter, that's my mu is compared to a specific value. In this case, I'm comparing it to 72. Is it the same or not? When testing the difference between two means, the values of both parameters, mu of g, in this case, and mu sub s, are compared to each other. That's the difference. Okay, so that's question 1 on your homework. Okay, that's question 1. Pretty straightforward, but an important thing to understand here. Now we're going to go on and do question 2. Let me share the homework here. And we have another assumption. Question 2 says, what 3 assumptions must be met when you're using the z-test to test differences between two means when sigma 1 and sigma 2 are known? Now, one thing you should know about testing two means, we actually have 2 tests for this, just like we do for one mean, but we're not going to cover the t-test for 2 means. We're only going to cover the z-test, the large samples. So we're only going to cover one test for 2 means. Now we are going to cover some other tests for 2 populations, but when you have 2 means, we're only covering the z-test. And let me show you the PowerPoint slides at this point, so you can see this. Now, these slides are pretty extensive, and we're going to cover quite a bit of ground in here. But for now, we're going to look at here's our assumptions. Assumptions for the test to determine the difference between 2 means. Each of these bullet points is an assumption, okay? So question 2 is on slide 3 of your notes. Both samples are random samples. The samples must be independent of each other. In other words, there's nothing about them that's related. It's not the same people at different times. It's not overlapping in any way. And the probability of being in one sample doesn't influence the probability of being in the other. They're independent of each other. And the standard deviations of the variable must be known. So we have to know sigma 1 and sigma 2. And if the sample sizes are less than 30, then the populations from which those samples are drawn must be normally or approximately normally distributed. So we have to be able to assume that we have a normal distribution somehow, or it won't work. Okay, so if you need to at this point, pause the video to write down the assumptions. This is material for question 2 on your homework. So you're just going to look at, this is question 2. This is homework question 2 right here. Homework question 2 is your 3 assumptions, okay? There they are. Pause the video at this point and you can feel free to copy them down. Okay. All right, moving on. Let me go to the real stuff that brought us here. Now, a couple of things that I want to bring up as far as the homework goes. Okay. Some of you are losing points on how you show your work with some of the homework. But there's a couple of nuances to this particular assignment, okay? First of all, when we're doing 2 groups or 2 populations, we always use the p-value approach, not because we can't use the other, but because we are using the calculator. It's a lot of calculations when you're doing 2 samples. It's even more than when you're doing a single sample. And she wants to cut down on some of that. So here, now, the other thing is that when we do it, and we're going to see this as we go through this assignment, okay? These directions up, let me pause the video. Where is my pause? So when you're doing data, and I actually have the data in my calculator already. So let me show you that. Here's the calculator here on the screen. Let me put the calculator up. So you're going to go to Stat. You're going to go to Calc. And I'm sorry. First, you're going to go to Edit, Stat Edit. Okay. And what I've done here is all of the United States lengths of the major rivers, I put that in L1. So everything you see on the list that says United States, I put it in L1. Everything that you see that says Europe, I put in L2.
Oh, okay.
And then I run my stats test from there. So the next thing I do, I'm gonna stall for time for you a bit while you put it in there. You can set up your hypothesis testing. So what I'm gonna do here is you go to the whiteboard and I'm gonna share I can get this out of the way. There we go. Share the whiteboard. So for number 3, this is how it's going to look. They're going to say, this is problem 3. So we start the way we always start, which is we say, what is the parameter? The parameter is the population mean. I like to put the population mean difference. She puts population mean, but I put population mean difference, and I put mu there. And then we're going to say that the next thing is we want to check for our claim. And if you remember, let me go back to the homework for a moment here. It says a researcher wishes to see if the average length of the major rivers in the United States is the same as the average length of the major rivers in Europe. So they want to see if the length is the same. So what we're going to do here is we're going to, let me go back to the whiteboard. Your claim here is going to be that the rivers are the same. So I'm going to say that this is HO because I have an equality. So mu1 is equal to mu2. And I'm going to make a note here that I'll put it underneath. This is my claim. I'm going to say that mu1 is the US rivers, and mu2 is equal to the European rivers, just so that we can keep that straight when we do it. Now, after we have the parameter, we have the claim, we need the method. And our method is the p-value approach. Always a p-value approach in this chapter when you're doing 2 populations. The p-value approach, and it's the test we use is the 2-sample z-test, and this one is with data. So we're going to put data there, and that becomes important. You'll see why, because she can give you raw data or she can give you the summary statistics. Now, from there, you can start doing your hypothesis test. So step 1 of this is we're going to record the null and the alternative and all of that. So very similar, if you've watched me do this before, if you've watched her do it before. Are you from the online class or the in-person class, Destiny? I don't think you and I have met before.
I'm in the in-person class.
You're in the in, so you watched her do this, right? HO is mu1 is equal to mu2. And H1 here would be mu1 is not equal to mu2. And they're not equal. And remember the claim here is that we're testing to see if they're the same, right? So our claim is HO here. And this is a 2-tailed test. This is a two-tailed test. Okay, so we've got that. Now, since we're doing the p-value approach, and one thing I should mention for the sake of those of you watching, because I noticed this earlier and I'm going to make her aware of it later, but something that you should be aware of, let me show you this, is that you're doing the p-value approach. Her directions here are for the traditional method. So step one is fine, but step two is actually to find the test value. And then step three is to find the p-value. So just be aware of that she has the wrong series of steps. These are for the traditional method. So just follow the p-value method steps when you do that. She has it correct on the key as far as I know, but not up here. So let me see what else we have going on. So here, we're going to, now, the nice part about this chapter is most of this you're going to get straight off the calculator. And you show very minimal formulas. You do show the steps, but you show very minimal formulas. Step two is the p-value. So you're going to say that your p-value here, I'm sorry, your test statistic, my apologies, your test statistic, and I'll show you how to get that in a minute. Your test statistic is going to come from the calculator, and I'm going to make a note that it comes from the two sample z-test for data, okay? Just for your own sake, because we already made a note up there. Now, for those of you who may be doing this for the first time, Destiny, have you had a chance to practice this or not yet?
Yeah.
A little bit? Okay. So once you put your data, granted, there's a lot of data in there, okay? Once you put your data in there, you're going to go to stats. You're going to go to tests, and you're going to look for something that says two sample z-test right here. Third one on my menu. And when you put this in, you're going to use, this is why you specify data or stats. Data means raw data like this, okay? Then you need the population standard deviations. She gave them to you in the problem. Sigma 1 for the US is 450. Sigma 2 is 474. L1 and L2, scroll down. Set your alternative hypothesis to not equal to and calculate it. Now, the first thing you see on this list is the z-score, okay? That's your test statistic. So our test statistic here is negative 0.8560, okay? Negative 0.8560. I'm going to write that down so that 8560 is my z. Now, the next thing you see is a p-value. That's your p-value on the next line. 0.3919, there's an 8 after it. So this is going to be 0.3920 is where this is going to round. 0.3920. Your X bar 1 and X bar 2 are the sample means for the river lengths. Your S's are the sample standard deviations, and then you have the N's for both. You don't need those unless you're doing it by hand, but they do not have to be the same size in order to do this. So now we basically have everything we need to finish this test. So what we're going to do is we're going to say that we're going to go here and we're going to write our test statistics. So we're going to say that Z is equal to, Z is equal to negative 0.8560. That's my, oops, it didn't show up. I'm not sure why. 0.8560. There's my. Okay, there it is. I think it's showing up now. 8560. It was. Okay, there. Think we're there. That's my Z. Step 3 is my p-value. So I'm going to make a note just because this was a little bit missing something. Step 3 here is going to be my p-value. So this, again, this comes from the calculator. So your p-value here is going to be the value that you get from what you saw. And that is going to be, p-value is going to equal 0.39, 0.3920. Why is it not? Okay. 39. Not sure why my Zoom is having a bit of an issue right now. 3920. So this is 20. Okay, 3920. That's your p-value. Step 4 is we're going to make a decision to reject or not reject the null by comparing our p-value to alpha. And I have to go back, but I believe our alpha here was 0.01, but I'll check that in a moment here. So step 4, we're going to compare p to alpha. So we're going to make a decision here. We're going to say reject. I'm going to say reject. Reject HO. Okay, let's try that. It's not reject HO or do not reject HO. And that means we do that on the basis of our p-value, and our p-value here is clearly larger than anything that alpha is going to be. But let me check my alpha. Let me go back and grab the homework here. It says at alpha is 0.01, is there evidence to reject the claim? The claim was that they're the same. So let me see. We have our Now we compare P to alpha. So at this point, we're going to say that our p-value was p-value having some issues with my mouse at the moment. P-value is equal to point 0 point, oops. Okay, that works. 39. 3. Okay, I don't know why. There it is. 3920. And my alpha is 0.01. 0.1. So now I can say that I'm going to say do not reject the null because P is greater than alpha. So I'll say do not reject HO because do not reject HO because P is greater than alpha. HO because did you have any other questions about this one, Destiny?
Would all of them be using p-value?
Yes. You're gonna use p-value because if you look at the slide, let me show you that. That's a good question. I'll come back to this in a minute. Let me show you the slides here for 9.1. So these were the assumptions that we did. And then if you look at the, when you do this, we will solve all the assignments in this chapter, not just the section, folks, the chapter. So that means 9.1, 9.3, and I believe 9.5. She's covering 3 sections of this chapter. Any of those sections, you're using p-value method, okay? And you're going to use the calculator to find the test value and the p-value. Okay, so no that's why I made the comment that I made about her steps at the top of the homework assignment, okay? Because there's no critical value here, it's all p's. Okay, so here, let's go back to the whiteboard. So we do not reject the null because p value, whoops. Okay, hold on. Because p-value is greater than alpha, okay? In other words, 0.3920 is greater than 0.01. Now, we do not reject the null. So if you want, you can box this. Some people do that too. And step 5, whoops. Step 5 is going to be we write our summary. Summary still works the same, so pay attention to what your claim is. Pay attention to what your decision was. So step 5, we have, remember for your own sake, let me write this in. So this is my summary. My claim here was HO. And my decision was do not reject HO. So I can say my summary will be there is not enough evidence, to reject the claim. And I underline the words is not and the words reject. There's not enough evidence to reject the claim. And that's all there is to problem 3. So it's considerably less grunt work than some of the previous ones, because your calculator is doing all the work. Now, an important thing to note about the rest of this homework is that, let me also show you this. If you look at the homework for this section, number 4 is a 2 sample, and she gives you the sample statistics. Number 5, the same. She gives you the sample statistics. Number 6, sample statistics. Number 7, sample statistics. Okay, so this is the only one with data. So in the other problems that you're going to be doing up to number 8, you're going to go to your calculator and put it on stat. So here, let me share the calculator screen. If I quit from here, if I go back to stat and show you that, let me share the screen here. Okay, do this like this. I believe you should be able to see my calculator on the screen right now. Yeah, so when you go and do this, you're going to do stats. You're going to do 2 sample z-test, just like before. And you're going to go to stats instead of data. And it's right now it's showing you the sample statistics from the one that I just did, but you can go and you can edit these manually for whatever your question is. So you're going to put in the sigmas, the X bars. Remember, these are X bars are the sample means. The N1 is your sample size, and your sigmas are there. Okay, and that's all you're going to do, and then just write. So basically, you're going to get the numbers from the calculator screen and just write the hypothesis test. The other thing to be aware of is that right here, when you get to number, I believe it's number 8. No, number 9, I'm sorry. 9 and 10, you're not doing a hypothesis test. 9 and 10 asks for the confidence interval, okay? Although on number 10, there is a question related to the interval, but 9 and 10, you construct the confidence interval. So what that means is that you're going to use the confidence interval commands on the calculator to construct that for you, okay? You have the mean, you have the population standard deviation sigma, and you have the sample size for your age groups. Okay. Anything else, Destiny, that I can help you with?
I'm good for now.
All right. Well, thanks. Okay. So somebody asked about number 10. So let me show you that. This is a confidence interval, okay? So it says adults aged 16 or older were assessed in 3 types of literacy: prose, document, and quantitative. The scores in document literacy were the same for 19 to 24-year-olds and 40 to 49-year-olds. A random sample of scores from a later year showed the following statistics. Okay, so what we're doing here is you're constructing the confidence interval. So just for some context, let me show you this. What you're doing here is you're looking at, these are all hypothesis tests. Okay, this is hypothesis test. You're looking at slide 17, okay? So stats test 2 sample Z interval, I'm gonna show you that. And then, so she gives you the interval. What she wants is for you to write what the parameter is, what the test is, and then the type of interval, and then you just write it out. So actually number 10, you're gonna do, it's gonna be this. Number 10 is gonna look like, so skipping to number 10 temporarily, let's do this. We're gonna have, this is number 10. We're gonna start with parameter. It's gonna be mean, put population mean meal. Population mean meal. And it's actually the difference in population means. Here you're doing a confidence interval. And it's going to be, we're using a 2 samp Z interval. I'll show you that. 2 samp Z int because of large samples. So what you're doing here is we're going to go back to, I have to go back to the homework first and grab the numbers because I need them. So my age group of 19 to 24-year-olds, I'm gonna, okay, so group 1 is group 1 here. Now this depends, I'm gonna have to look at her mechanics because I may end up with a negative number here. Mu1, let's see, X bar 1 is 280. So I'm gonna have, let me do this. Let me put it down here. And I'm gonna say, hold on, let me try and get my calculator screen up again, because I had this as a split earlier. And I don't have it like that right now. So let me see if I can make that happen. No, okay, I'm just gonna. So this is, I'm gonna do this like this. Okay, so here I am. And let me then. All right. So let me share this screen and see if we can see this. I think you should be able to see both on my screen. Can you?
I can see both.
Okay. So now I'm gonna start from the beginning. So let's say we're here. This, you just turned your calculator on and look something like this. You're gonna go to stats again. You're going to go to tests, because this is considered a type of test. And you're gonna look now on this menu, everything that ends with test is a hypothesis test. Everything that ends with interval or INT is a confidence interval. We're looking for, be careful, number 7 is a Z interval, that's one mean, that's not what we want. We want this one, a 2 sample Z interval. We want this one here. So we're going to hit enter. And then we have a choice. Are we using data? Data would be those lists of numbers like we saw with number 3. Or do we have what we call the summary statistics? These are summary statistics. So we're using stats. Go to stats, make sure it's highlighted, hit enter, and then just enter the data that she gives you. Now, sigma 1 is the population standard deviation for group 1. So we're going to say, I'm just going to call, for the sake of this example, I'm going to call the 19 to 24-year-olds group 1 and the 40 to 49-year-old group 2. Okay, so that means sigma 1 is going to be 56.2. So I'm going to enter 56.2 there. Sigma 2 is going to be 52.1. Like so. Then X bar 1 means the sample mean for group 1. Sample mean is your mean score, so that's 280 for group 1. Your sample size for group 1 is 40. Okay. Your sample mean for group 2 is 315. And your sample size for group 2 is 35. We want a confidence level. Okay, what confidence level do we want? Construct a 95% confidence interval. So here, we're going to enter 0.95 as my confidence level. And I'm going to calculate that. And there it is. Now, the reason these are both negative, the mean differences are negative, is that the mean in group 2 was larger. So when it went to subtract it, we were taking a small number minus a big number. And so we got our confidence interval. So our confidence interval here, this I will write down. This is negative 59 52 and negative 10.48. Now, we're going to go back to the whiteboard here. Go to the whiteboard. And when we write it, we're going to say something like this. We're going to say negative 50.52 is less than. Now remember, this is the mean difference, so it's actually mu1 minus mu2. And you can specify your groups if you were told to do so. This is negative 10.48. Okay, that's my interval. My mean difference is basically 51 points under to 10 points under. Now, the more important question for this is the question that she asks after that, which is, let me show the homework. Here, it says, what does your interval say about the claim that there is no difference in mean scores? Okay, well, this is her little nod to hypothesis testing with confidence intervals without giving you the whole thing. Okay, the claim is that there is no difference in mean scores. This is not a hypothesis test per se. She's just asking you a question. So you would say, whoops, you would say this. Now, think about this for a minute. If there's no difference in mean scores, right? Then what we would be saying is that the means are the same. If there's no difference, then mu1 is equal to mu2. If there's no difference, then this difference should be 0, right? But our interval goes from negative 50 to negative 10. The interval doesn't contain 0. So here we can say, since the 95% confidence interval for the mean difference, for the, if you want, you can add population mean difference, does not contain 0. In other words, 0 is not in this interval because it goes from negative 50 essentially to negative 10 and some change. Since it doesn't contain 0, the claim that there is no difference in mean scores. So we say there it is. A claim that there is no difference in mean scores is not supported. It doesn't support it. If 0 were in the interval, then we could say that, but it is not in there, so we don't support that. Let me see what she actually wrote, because as I said, this is not a formal hypothesis test. So just to see what she actually wrote in there, let me take a look. It says, okay, so we got our interval right here, which is not accept. Okay, so she did change this. I wasn't sure if she changed it. I'll go back over that and do that. So yeah, there is, the interval provides evidence to reject the claim that there is no difference in mean because 0 is not it. Okay, so a couple of things about this. I wasn't sure how she was going to teach this in the classroom for those of you watching, but she often does not like negative values on both sides of the interval. So what we're going to do is we're going to change the groups. Now that sounds hard, but let me show you something. We're going to go back. We're going to do stat. So this is going to be, let me make sure I'm sharing. Yes. Okay. We're going to go to stat. We're going to go to calc. And tests. And if you remember, when we came down here, I said it was a 2-sample Z interval. And I also said that it was going to come out negative because sigma 1 and sigma. So what you want to do, keep this on stats and just change your groups around. So essentially, everything that was group 1, let me go back here to the data so we can read it from the worksheet. There it is. We're going to read this from the worksheet. I'm going to bring my screen up here. Okay. And so all I'm going to do essentially is I'm going to call, instead of calling this top group, group 1, I'm going to call the bottom group, group 1, and the top group, group 2. And something interesting is going to happen. So all I'm going to do is so group 1, your sigma 1 is going to become 52.1. So this is going to be, hold on, need my mouse. So this is 52.1. Okay, I need to use my, okay, 52.1. And my sigma 2 is 56.2. My X bar 1 is 315. My X bar 2 is 280. My sigma, oh wait, sorry. You know what I did? This happens to me a lot. I forget that this N1 is the sample size. N1, the sample size for that was 35. So let me change this. My X bar 2 is 280. 280. And my N2 is 40. I'm going to take an extra minute and check that. So 52.1 is sigma 1. And 56.2 sigma 2. X bar 1 is 315. N1 is 35. X bar 2 is 280 and 40. Good. Now, oops. Apologies, folks. I hit the wrong key. Stats, test, 2-sample Z interval right here. Got all our numbers in there. Still running a 95. calculate it one more time and something interesting happens. We get the same interval, but now the numbers are reversed and they're positive. So 10.48 to 59.52. So all I'm going to do here is change the this still holds, but I'm going to change the way this interval is written. So 10.48 to 52.52. So I'm going to say that I'm gonna leave it here, but I'm going to say you're going to report this interval. You're going to say that 10.48 is less than mu. And you just switch the names of the groups. Mu1 minus mu2 is less than 50.52, where group one is the 40 to 49-year-olds, and group two is the 19 to, I forget how old they are, let me check. This is 19 to 24.
19 and 24.
Okay, so, and again, our conclusion is the same. So we say that the interval provides evidence to reject the claim that there is no difference because 0 is not in it. So we would reject the claim that there is no difference. Okay. So technically this is not a hypothesis test, like I said. If it were, and you're testing no difference, then you would say there is not enough evidence to support, because no difference would be mu1 is not equal to mu2. But the point here, let me show you this, because this is in her last slide on the slides. So this is, let me show you the slides here. So once you do your interval, this was a different interval, obviously, but what she's after here is this thing here. And so she's after this part, okay? You can, what you look at is we're doing, you enter the appropriate values, you move the cursor to the data. So this starts on slide 17. And this bullet point is the one that you want to follow. If the confidence interval contains 0, which it doesn't. Remember, our interval did not contain 0. It went from 10 to 50 and some change. Right? Then do not reject HO because it contains 0. Remember, our mean difference is 0. But in this case, we would reject. So, I mean, you could write the whole hypothesis test, but I don't think she wants you to do that. She didn't say perform the hypothesis test. She just asked you about the claim. So I think to write it, I'll verify with her, but I believe, did she say anything in class about this? Destiny, or she didn't get that far?
I wasn't in class for this. So
Oh,
I
okay.
reviewed over the
I see.
notes.
Yeah, no, I'll have to ask her about it because I wouldn't think that she would, but I'll ask her and find out. But it's not that big a deal. I can always make a follow-up if I need to for that, but that's how that works. Okay, that's how that whole thing pans out. Can I help you with anything else? Destiny?
Could you repeat yourself, please?
Sure, I was just asking if you needed help with anything else.
Oh no, I'm good now.
Okay, all right then.
Thank you.
Before you go, let me pause the recording. Before you go, I want to give you credit for being